Okay, so in this problem here, we are asked to find the voltages, or define the voltage at nodes A, B, C, and D. So they want to know what is the voltage at these four spots in this circuit. So you'll notice there's a ground right there, and there's a ground right there. Um, so we're going to be somewhat careful about that when we're finding these voltages. So let's begin. Okay. Well, the first thing I notice is this. That so the current IT flows like this, right? All of IT is leaving the source, and all of IT is entering the source right there. And then it hits this node, and the current is going to split. So the current is going to go around this bend like this. I'm going to call this one I1. Okay. And then I've got more current going this way. I'll call it I2, and we'll deal with what that's doing in just a moment. So first thing I see here is that there's 25 volts across this string of 3 resistors right here. So that is a pretty good candidate for voltage division right there, because then I think I can pick off voltage A, voltage C, because I know the voltage right here, it's 0 volts, right? So my voltage drops are going to look like this. Every place where the current enters a resistor, I put a plus, and everywhere where it leaves, I put a minus. So moving this way, a plus to minus is a voltage decrease. A minus to plus is a voltage increase. So anyway, let's do this voltage division. Well, the first thing I want is voltage C. I know that voltage C right here is going to be the voltage across this, because we've got a ground 0 volts right there. So whatever this drop is, that's voltage C. So voltage C is going to be 25 volts. That's the voltage between here and here. And we are going to divide it. What's the thing I'm looking for the voltage across? That 25 ohm resistor right there. And what's the total resistance of the voltage divider? Looks like it's going to be 175 ohms. So let's see what VC is. 3.57. Okay. So that's VC. VA, so for VA, we're looking for the voltage between here and here, because this is 0. We're looking for the drop across this and this. So VA is going to be this. 25 volts, that's the voltage being divided, times what's the thing I'm looking for the voltage across? This 75 ohms right here. So 75 divided by 175. Let's see what that voltage is. So that's going to be 10.71 volts. Okay. All right. So, how are we going to deal with this? Well, let me think about this for just a moment. So we've got I2 going this way. I think what I am going to do is I am going to collapse this and these two. So I can see that this spot right here, we've got 100 ohms to ground, and then we've got 65 ohms to ground. So this and these two are in parallel. So let me redraw this bit of the circuit. I'll do it right here. So here's the 25. These are the ones we just solved for. All right, and here's our 100 right here. And then this and this are going to be in parallel, like this. I'll just draw it this way for now. So this is going to be 100 in parallel with 65. So let me see what that is. 100 times 65 divided by 165 is 39.39 ohms. All right, and you'll notice that this spot where both of those things touched, it was voltage B. All right, so this is another case of voltage division. So VB is equal to the drop across this. That's going to be 25 volts, right? Because it's 25 here and 0 here, times 39.39. That's the thing I'm looking for the voltage across, over the whole divider. So that's 139.39. Let's see what VB is. 25 times 39.39 divided by 139.39. 7.06. So that's VB. All right, and then we want to know VD right here. Well, you can see between here and here, there's 7.06 volts. This is 0, that's 7.06. So once again, we've got a two-way divider. So I just want the voltage across the 25. Well, it's going to be 7.06 times 25 divided by what's the resistance of the whole divider? 65, right there. So that's going to be 7.06 times 25 divided by 65. I got the wrong answer because I keyed in the wrong thing. 7.06 times 25 divided by 65 is 2.71 volts. We did it. So we have found VA, VB, VC, and VD. Okay, that is it for this video.